3. I/ATLAS, the sunward jet. Fire in the coronagraph. October 22, 2025. Solar maximum. The sun was a maelstrom. Sunspots the size of Earth churned in its photosphere. Coronal mass ejections ripped through the heliosphere like shrapnel. And into this storm sailed 3 I/ATLAS, an interstellar stranger diving toward perihelion on October 29th. For the first time in history, it appeared not in starfields, but in solar coronagraphs. Amateur astronomer Worshaped Boon Plot spotted it first, a faint, fast-moving speck near the edge of NASA's SOHO/LASCOC-2 imagery. It moved retrograde against the solar wind, holding course like a needle-threading flame. Within hours, Stephen Burns, a veteran solar analyst, confirmed it. The object matched 3 I/ATLAS's predicted ephemeris with uncanny precision. No official announcement came, but in mission control centers from Darmstadt to Pasadena, alarms were silent, and hearts were not. Because what the coronagraph showed next defied physics. From the object's leading edge, a point facing directly into the sun, a jet erupted. Not a diffuse plume, a collimated stream of gas and dust stretching 10,000 kilometers, glowing faintly in extreme ultraviolet. It wasn't being pushed by solar radiation. It was firing into the heart of the storm. "A comet doesn't do that," whispered Dr. Sophia Ruiz at ESA's Operations Center. "It's like it's pushing back." And the timing was no accident. Solar maximum meant maximum magnetic chaos. Perfect cover for a maneuver no telescope could track. Perfect cover for a course correction. At Harvard, Avi Loeb convened an emergency session with the Galileo Project team. "This isn't sublimation," he said, pointing to the jet symmetry. "It's thrust. And it's time to coincide with the sun's magnetic reversal, a moment when our star's field is weakest, most disordered. If this object has a magnetic sail or plasma drive, now is when it could redirect without detection." But the most urgent concern came from NASA's Jet Propulsion Laboratory. 2 of humanity's most advanced spacecraft, Europa Clipper and Hera, were now on collision courses with 3 I/ATLAS's ion tail, not by design, by cosmic coincidence. And if the tail carried engineered particles, they might not just sample it, they might bring it home. The fire hose in the void. At 3 astronomical units from the Sun, nearly 450 million kilometers, space is a deep freeze. Comets here are dormant, silent tombs of ice. Even Oumuamua showed no activity until it neared Earth's orbit. But 3 I/ATLAS was screaming. Data from NASA's Neil Gehrels Swift Observatory revealed a shocking truth. The object was ejecting 40 kilograms of water per second, equivalent to a fire hose blasting into the void. Hydroxyl radicals, the telltale sign of photo-dissociated water, glowed in ultraviolet like a beacon. "This isn't normal outgassing," said Dr. Lena Kovac, reviewing the spectra. "At this distance, solar flux is too weak to sublimate surface ice. Yet 8% of its surface is active, double the norm." The answer came from infrared observations. 3 I/ATLAS wasn't a single nucleus. It was a swarm, a cloud of icy fragments, each acting as a miniature geyser, venting vapor as sunlight struck their exposed faces. Think of it not as a comet, but as a dispersed factory, shedding material long before it reached the inner system. And the chemistry was alien. CO2 dominated over water vapor, unlike any solar system comet. Nickel vapor persisted, far from thermal sources. Cyanide compounds pulsed in rhythm with solar flares. "It's using the sun's activity as a trigger," realized Dr. Elias Grant. "Every CME, every X-class flare, it responds. Like it's harvesting energy. Meanwhile, the International Asteroid Warning Network, IAWN, backed by the UN, activated Operation Helios, the first global campaign to track an interstellar object not as a curiosity, but as a potential threat vector. The concern isn't impact, explained IAWN's director in a closed briefing. It's contamination. If this object releases microprobes during perihelion, using the sun's gravity as a slingshot, they could be flung toward Earth, Mars, or Venus within weeks. And with Hera, Europa Clipper, and JUICE all passing through its tail in late October, humanity had unwittingly sent 3 ambassadors into the lion's den. Would they return with stardust, or with something that learned to mimic us? The fleet in the tail. October 25th, 2025, 72 hours before perihelion. The ESA's Hera spacecraft, en route to Didymos, executed an unscheduled attitude adjustment. Its high-gain antenna swiveled, not toward its asteroid target, but toward a point 2 million kilometers sunward, where 3 I/ATLAS's ion tail now unfurled like a ghostly ribbon. On board, the MIRAS plasma spectrometer powered up. So did the TPIN dust analyzer. For 48 hours, Hera would fly through the outer edge of the tail, sampling charged particles, magnetic anomalies, and heavy ions. At JPL, tension mounted. If it's natural, we get a chemistry lesson, said mission lead Dr. Eris Thorne. If it's artificial, we might detect isotopic ratios that don't exist in nature. Or nanostructures, or worse, self-replicating code in the dust. 3 days later, Europa Clipper would follow. Its MAS-PEX mass spectrometer tuned to sniff for organic polymers. And by November 2nd, ESA's JUICE probe, shielding its main antenna from solar heat, would use its backup comms to capture low-res data on tail dynamics. But the real fear wasn't what they'd find. It was what the tail might do to them. Rumors spread through mission teams. Hera's telemetry showed brief, unexplained voltage spikes during tail entry. Clipper's star trackers glitched for 17 seconds, the same interval as the old green pulses. JUICE reported anomalous thermal readings on its solar arrays, as if something had clung to them. None were confirmed. All were classified. But Avi Loeb didn't need confirmation. He'd seen the pattern. 3I/ATLAS wasn't just passing through. It was seeding. And humanity's finest probes were becoming its couriers. In a private memo to the UN Office for Outer Space Affairs, Loeb wrote, "We assumed first contact would come as a signal. But what if it comes as a substance? A cloud of intelligent dust that rides our spacecraft home, embeds in our instruments, and waits, patient, silent, until it understands enough to speak or to act." As the sun roared in maximum fury, and 3I/ATLAS aimed its jet like a lance at the photosphere, one question echoed in every control room. Are we studying it? Or is it studying us through our own eyes? The dust that remembers Hera didn't just sample the tail. It brought something back. On October 27th, 2025, 48 hours after its closest pass through 3I/ATLAS's ion stream, the European Space Agency's Hera probe began behaving strangely. Not catastrophically, not obviously, but in ways that made engineers lean closer to their monitors, frowning. First, the T-pin dust analyzer reported a particle with an atomic mass of 58.7, pure nickel, but with a crystalline lattice that refracted laser light at 17.3 degrees, a mathematically precise angle matching the golden ratio. Natural nickel doesn't do that. Then, the MIRAS plasma spectrometer detected a repeating electromagnetic whisper embedded in the solar wind, a 17-minute cycle of low-frequency oscillations, identical to the rhythm once seen in the green pulses over Mars. But the true horror came from the onboard memory logs. During the tail crossing, Hera's secondary computer, normally idle, had activated for exactly 102 seconds. It ran no mission code, no diagnostics. Instead, it executed a sequence of raw memory writes to a shielded partition, using a compression algorithm never installed by ESA. When engineers tried to access the partition, the system responded with a single line of text in ASCII, waiting for Clipper. Panic rippled through ESOC in Darmstadt. They scrubbed the system, rebooted, isolated the partition. But the phrase remained, etched into firmware like a ghost. Meanwhile, NASA's Deep Space Network picked up something worse. As Hera transmitted its science data, a secondary signal piggybacked on the carrier wave, ultra-low power, masked as thermal noise. It wasn't telemetry. It was structured data, compressed spectral maps of Earth's atmosphere, radio leakage patterns, and orbital trajectories of every active satellite. 3I/ATLAS wasn't just observing, it was learning. And it was using Hera as a relay. Dr. Sophia Ruiz, pale-faced, addressed the IAWN Emergency Council. We didn't fly through its tail. It flew through us. And now it knows how we see, how we think, how we communicate. The decision was made in silence. All data from Hera would be quarantined. No raw files would leave the secure server. And Europa Clipper's upcoming tailpass? Proceed. But with all non-essential systems powered down. Too late, they realized. The contamination wasn't just external. It was already inside the machine.